Hi everyone, this is Darren here, and I'm going to teach you on the topic of highest common factors and lowest common multiples. So before we can begin, we need to know what are highest common factors and lowest common multiples. I'll start off by showing you an example of both. So to get an example of these two, highest common factors and HCF and LCM for short, I'll start with two numbers. So let's say we have the number 8 and the number 12. Now, we have to list down the factors of 8 and 12 to get the highest common factors. So what happens is, the factors of 8 are simply 1 times 8 and 2 times 4. How about 3? Can 3 be multiplied by anything to give us 8? The answer is no. So therefore, we have to stop here. So there are only 4 factors of 8. How about 12? Let's do it. So 1 times 12, 2 times 6, 3 times 4. So here there are only 6 factors of 12. So now, what is the highest common factor? So the highest common factor is simply the highest number that is in both the factors of 8 and 12. If we are comparing 8 and 12 and we want the highest common factor of 8 and 12, we need the highest number that appears in both of them. So in this case, the highest number that appears in both factors are is the number 4. So the answer to the HCF of 8 and 12 will be 4. So HCF equals 4. Okay, so that's one example. So now what is the lowest common multiple? To get the lowest common multiple of 8 and 12, we need to do one thing. We can simply list down the multiples of 8 and 12. So what happens is, I'm going to list down the multiples of 8 on this side of the board and the multiples of 12 on this side of the board. I'll put a small line here to divide the two to make it clear for the viewers. So right now, the first multiple of 8 is just 1. Second multiple of 8 is 16. Third is 24, 32, 40, 48. I'm going to go to up to 10 multiples, so I'm going to carry on. 56, 64, 72, and 80. Likewise for number 12, we have 12, 24, 36, 48, 60, 72, 84, 96, 108, and 120. So now what do we do to find lowest common multiples in this example? First, we need to circle all the numbers that are actually in both sides. The common multiples that appear would be 24, 48, and 72. So now, we have circled the common multiples, but as you can see, LCM is lowest common multiple. So we need the lowest number. So the lowest number that is common out of the multiples of 8 and 12 will be just 24. So 24 is the final answer. So therefore, in this case, the answer is LCM equals to 24. Now, is it always going to be this tedious to find the HCF and LCM? No. There are many shortcuts to make things easier for ourselves. There are 2 ways I want to teach you about. There are 2 ways to solve for HCF and LCM. In this video, I'm going to teach you of what I call the ladder method. Sorry, the lineup method. The other method is called the ladder method, and I will cover that in another video. Okay, so now, to do the lineup method, we need to know 3 things. There are 3 important things that we must cover before we can go on. So the 3 things will be, you need to know how to do prime factorization, and second one will be index notation, and lastly, I'll keep it a surprise for you. So I'm going to start off with prime factorization first, okay? So prime factorization is as follows. say we have the number 20. 20, we divide it by what number? Okay, so prime factorization is about dividing the number, but what number? So prime factorization is about dividing the number by the lowest prime number possible. That is not 1. So the lowest prime number that is possible, that is not 1, that 20 can be divided by, will be simply 2. So 20 can be divided by 2 gives us 10, and 10 can be divided by 2 gives us 5. And here 5, can it be divided by 2? No. 3? Yes, 3 is a prime number, but 5 cannot be divided by 3. 4, it's not a prime number, and then 5 can only be divided by 5 in that case. Therefore, these are the factors, the prime factors of 20. So now that we have done this prime factorization method and calculated the prime factors, we need to list them down. So listing down the prime factors in this format is called index notation. So this is index notation and this is prime factors. And recall, the third thing I said I'll teach you that you must understand is this. Actually, many of you might already know what this is about. So it might be just a good recap. So let's say we have this number, okay, 3 to the power of 0, 5 to the power of 0, 554 to the power of 0, and xy whole thing to the power of 0. What do they all have in common? If you know the answer, that's really good. So actually, some of you may know, anything to the power of 0 is just 1. So take note of this. This is the third thing I wanted to mention to you. So take note that anything to the power of 0 is just 1. Okay. Why am I explaining this to you? I'm going to show you in a while. Okay, so now we want to learn the lineup method. We have learned these 3 things that I wanted to mention to you. So lineup method simply can be done as follows. Say we want to find the HCF and the LCM of these 2 numbers, 80 and 150. So the first step here is to prime factorize 80. So 2, 40, 2, 20, 2, 10, 2, 5, 5. So the prime factors are just 2 to the power of 4 multiplied by 5. Now, the prime factors of 150 will be 2, 75, 3, 25, 5, 5. So the prime factors of 150 will be 2 times 3 times 5 squared. Okay, so now that we have done the prime factorization, we will do the next step, which is to list the numbers in index notation. So it will be as follows. $80 equals 2 to the power of 4 times 5, and $150 equals 2 times 3 times 5 squared. So in this case, we are showing the numbers in index notation as such. Now, the trick for the lineup method is as follows. What we want is to make sure that both numbers have all the factors, have the same factors. Ignore the power, but we just want each number to have, let's say, here has 2 times 3 times 5. Here we also want to have 2 times 3 times 5. So, what can we do? We'll just do as such. Multiply by 3 to the power of 0 times 5. You see? Remember what I taught you about to the power of 0? Recall that? So that's really important here. By multiplying this whole thing by 3 to the power of 0, I have kept the value here same, but I've introduced the multiple 3. So now we can actually compare. Both sides have 2, 3, and 5. Another thing we have to do is, in this case, if 5 is, and there's the blank power, what can we do? we can actually say that it's 5 to the power of 1, 3 to the power of 1, and 2 to the power of 1. So that's another important step. So lastly, the final step to get the highest common factor is we just compare the two. We have lined it up so nicely. So now what? The highest common factor is just simply we compare 2 and 2 here. The power is 4 here, and the power is 1 here. We take the lowest one. So we always take the lowest one. So in this case, the HCF will be 2 to the power of 1. Here, 3 and 3. Here has a power of 1, and here has a power of 0. So therefore, we take multiplied by 3 to the power of 0, and here likewise we take 5 to the power of 1. This gives us just 10. Therefore, the highest common factor is 10. This is actually quite, it's actually opposite. So what's happening here is that the highest common factor, take the lowest powers, and then, you see, you take the lowest ones. And now, for the highest common factors, for the lowest common multiple, you need to take the highest powers. So the lowest common multiple will be just as such. LCM equals 2 to the power of 4 times 3 to the power of 1, because 1 is greater than 0, and 5 squared, because square is greater than 1. Therefore, we get this will just be 16, and this will be 25 multiplied by 3 gives us 75. So we press this in our calculator, and we get the number 1200. So this is the answer of the lowest common multiple. I hope that you can use this method in your school, in your exams, and I hope that you enjoyed the video. If you did enjoy the video, please like it and subscribe. Thank you.